Hey, this is Chris Plush from CG Masters, and this is another lecture from our course, The Blender Encyclopedia, which has over 52 hours of content and over 430 tutorials. Normals are something that were a little tricky for me at first when learning Blender, so I thought this might be a good video to share on our YouTube channel as well for anyone that wants to learn more about them, so I hope you like it. In this lecture, I'll be explaining what normals are and what their primary purposes are. Then later in this section and in other sections of the course, we'll get into editing normals. You honestly don't need to watch this lecture in order to watch the rest of the course, but it's pretty important to at least be somewhat familiar with the concept of normals. So at the very least, I would skim through this lecture. I'm going to keep things simple here too. So in short, normals are simply the direction of a face or a vertex, and we'll start with face normals. So let me tab into edit mode of this shape right here, and then in the viewport overlays menu here, I'll turn on face normals all the way down here by clicking on that icon. So these blue lines here represent the normals, which basically just show us the direction a face is pointing. And that's seriously all a normal is. Now every face has two sides, as you can see. It has an outside and an inside. The side with the blue line is considered the outside of the face, and the inside has its own normal too, pointing in the opposite direction, but this one is obviously not displayed. Knowing which side of a face is outside is actually important for various reasons. One of those reasons is that the outside normals are used to calculate vertex normals. But now, what are vertex normals? Well, a vertex has direction too, just like a face, and vertices point in the direction that's an average of the surrounding outside face normals. For example, check out this 90-degree angle right here. In fact, let me go into front view by pressing numpad 1. We can see that a little bit more clearly right here. We have the outside face normals displaying right now, and you can see the top face's normal is pointing straight up, and the side face's normal is pointing straight to the right. So the vertex normals here should be pointing 45 degrees, which would be a perfect average of this direction and this direction. So let me go up into the viewport overlays menu here, and I'll turn on vertex normals by clicking on that icon there. And there you can see our vertex normals are pointing exactly like I said they would, 45 degrees, which is a perfect average of the surrounding outside face normals. In fact, to better illustrate this, I can select these two vertices, and back in front view, I'll move them up to change the angle of that top face. And you can see as the angle of this face changes, the angle of the vertex normal changes. And that's basically all there is to it. So the basic definition of a normal is pretty simple. It's just the direction an element is pointing. But now, what are normals used for? Well, their main purpose is for lighting the surface of a model. So let me tab out of edit mode of that shape, and I'll enable example 2 collection over here, which has a different example for us to use. Now we're going to start things off simple by first describing how flat shading is calculated, and then we'll get into smooth shading. Flat shading essentially uses face normals to determine how bright a face should be. So let me select this cylinder, and I'll tab into edit mode. And let me go up into the viewport overlays, and for right now I'll turn off vertex normals since right now we're just dealing with face normals. So the general concept of using face normals for flat shading is actually pretty simple. The more the face's normal is pointing toward a light source, the brighter that face is, which seems pretty obvious. So let me turn on material preview mode so we can actually use the real scene lights. So I'll press the Z key and choose material preview. So you can see we have a sunlight over here pointing at the one side of the cylinder. And you can see that if a face's normal is pointing more toward the light, the face is going to be brighter. And if a face's normal is pointing away from the light, like the faces back here, those faces are going to be darker. So that's pretty simple stuff. And don't forget the faces have two sides too, each with their own normals. So that's why the outside of these faces here are darker since their normals are pointing away from the light. But the insides of those faces are actually brighter because the normals for that side of the face are pointing toward the light. And that is flat shading in a nutshell. Every side of every face is illuminated individually based on how much their normals are pointing toward the light. Well, how then does smooth shading work? Well, let me go back into solid shaded view and let me hide the lamp for right now. We don't need that anymore. And to start things off, we'll actually smooth shade the cylinder. So let me right click and I'll choose shade smooth. Now we have a nicely smooth shaded cylinder. Now smooth shading is where vertex normals come into play. So let me show you. Now let me go into top view and we can see the outline of our cylinder right here. Now let me also enable this collection right here called vertex normals, and here I've drawn the direction of all the vertex normals for the cylinder. Now when we flat shade faces, a face has one normal. So this face right here, for example, would simply point in this one direction. And the entire face's brightness depends on that one direction. But when we smooth shade faces, this face would become a blend of this vertex normal and this one here. So for this face right here, here's what that blend would look like. Now you can see what I mean about the face becoming a blend of the vertex normals. Now there's probably more to it mathematically, but this is just a way to visualize what's going on. So the normals for this face right here, they start from this vertex normal pointing straight up, rotating downward to this vertex normal on the other side of it. So instead of a face having one direction giving it one brightness value like in flat shading, each part of the face is going to be brighter or darker depending on the direction of these normals. And when we do that blend for every face on the cylinder, the normals look like this. So all the normals pointing outward in a radial way like this is what gives the cylinder a smooth, rounded look when we smooth shade it. And that's basically all there is to it. So with all the basics out of the way, there are a few important things I want to go over. The first is something called flipped normals, and it's an issue that you'll encounter a lot. Now let me enable the next collection here. And this has a cylinder in it with more faces, which is just going to help me explain the issue better. So sometimes the outside of a face can be pointed inside of a model, and this can have a bad impact on your shading. For example, right now the cylinder is perfectly smooth shaded. Let me tab into edit mode, and we have face normals displaying already, and you can see they're all pointing outside of the cylinder right now. Now let me go into front view, and I'll press Alt and A to deselect everything, and let's enable face select mode here, and let me select these four faces right there in the front. Now let me press numpad 7 for top view, and you can see the faces I have selected right there are pointing outward. But let's make them point inward and we'll see what kind of problems that causes. So I'll press Alt and N for the normals menu and I'll choose to flip the normals. And now you can see that this flips the direction of the outside faces, so now the outside faces are pointing inward and are no longer in line with the other outside faces. Now let me tab out of edit mode and let's rotate the view and check out the smooth shading. You can see it's gone crazy. So why did this happen? Well, we know that vertex normals are an average of the outside face normals. So let me go back into top view and tab back into edit mode. So check out these face normals down here. We have one face normal going down and one face normal going up. So the average between these face normals is going to give us a vertex normal here that's going sideways. Let's see if we're right. Let's go up into the viewport overlays and I'll enable vertex normal display there. And we were correct. We ended up with a couple of vertex normals going sideways, as you can see there. And like we learned about smooth shading, it's a blend between vertex normals. So if the vertex normals are screwed up like this, then the smooth shading is going to be messed up too. That's why we ended up with those weird lines right there, because that's exactly right where those vertex normals are going sideways. Now let me tab back in, and we got a lot of normals displaying right now. Let me switch off vertex normal display, and we'll just deal with the face normals right now, since that's what we need to fix. Now, flip normals are actually a pretty common occurrence too. They happen for various reasons, including mirroring faces, which always results in flip normals, or it can happen when making new faces. When new faces are created, Blender assigns one side of that face to be the outside of the face, and this sometimes is not in line with the rest of the faces on the model, so you end up with inconsistent normals which can create shading issues like the one we see here. And the solution for this is really simple. We can simply press A to select all the faces, and then press Shift and N to do something called recalculating normals. And that's it. You can see those faces are now pointing outside along with the rest of the faces of the model. And now because all of the normals are pointing in the same direction and are in line with each other, that fixes up the shading issue as well. Now what's happening when you recalculate normals is Blender tries to figure out which side of your model is considered the outside of a model, and it'll point all of the outside normals in that direction. And it made all the normals consistent with each other, and it fixes up the shading issues. Now let's move on to another important note about normals. In Blender, the rule is to keep your outside normals pointing in the direction that's rendered, meaning if the outside of the cylinder is what's going to be visible in the render, make sure your normals are pointing in that direction like they are right now. However, if we were to rotate this cylinder and make it more like a tunnel that we'll be inside of, we'll need to flip the normal so that they're on the inside since that's what's going to be rendered. So we're going to want to flip these normals now to get them pointing in the direction that's rendered. So I'll press Alt and N for the normals menu and choose flip. And now all the normals are pointing inside. Now the direction of the outside normals is important for various reasons, like for things such as normal maps. And we'll get into them later in the course, but they're basically a clever way of defining how light bounces off the surface and allows us to fake high poly details on low poly surfaces. Now let me enable the light I have in this collection. You can see I have it there at the top of the tunnel. And then I'll press the Z key and we'll go into material preview so we can actually use that light. And let me tab out of edit mode for a second as well. And you can see I have a brick normal map already on the surface of the tunnel here as well. So we have the light at the top of the tunnel here shining down. And if we zoom into the bricks, you can see the tops of the bricks are illuminated by that light just like you'd expect them to. However, if I tab into edit mode, and with all the faces selected, if I press Alt and N and flip the normal so they're pointing outside, you can see the lighting on the bricks change. The tops of the bricks are now dark, and the bottoms of the bricks are now light. So it sort of makes the bricks look like they're inset instead of popping out, which is how we'd want them to be. So the direction of the outside face normals actually affects the way normal maps are calculated. And that's one good reason it's important to make sure your normals are facing the direction that's rendered, because they can affect things like normal maps. Above all though, it's most important to make sure your face normals are just consistent in their direction. Because like we saw earlier, we had some faces pointing inward and some facing outward, and we ended up with some serious shading issues. So keep that Shift and N hotkey in mind to recalculate normals. And if you have any shading issues, this is usually a good first step to troubleshooting. Now let me tab out of edit mode and I'll enable the next collection here. And let me go back into solid shaded view. Now to end the lecture, I just want to mention that normals are also used for some other purposes like transformations. Like in the transformation orientation lecture in the last section, we learned that we can move faces along their normals, meaning we can move this face, for example, along its normal in that direction if we want to. To do that, I'll just select the face, go up into the transformation orientations and enable normal. Now to move it along the vertical axis of that normal right there, I'll press G and then Z. And you can see instead of moving along the global Z axis, it's moving along that normal's direction. And it also works sideways as well. For example, G and then X, and G and then Y. So it'll make all the movements based on the normal of that face. Normals are also used for particle systems. The outside normals define which direction particles will be emitted from. For example, I've already added a particle system to this plane. If I press spacebar to play the simulation, you can see that the particles are being emitted, at least initially, in the direction of that normal. And then gravity's taking over and pulling them down. And normals are often used in various ways in modifiers too, and we'll go over that in the lecture of any modifier that uses normals. And later in this section we'll go over how to edit normals and why this can be useful. But I'll end this lecture here because I just wanted to focus on the concept of normals and what they're used for, so I'll see you in the next lecture.